GraphQL was open sourced out of Facebook, and it gave developers a way to unify their different data sources into a single endpoint. Although the promise of GraphQL is appealing, the process of setting up a GraphQL server that can communicate with each disparate data source can prove to be complex. Scaffold.io provides GraphQL as a service, and today's guests are the creators of Scaffold, Vince Ning and Michael Paris. Scaffold lets developers configure their schema and hosts their data. Vince and Michael explain the basics of GraphQL, and they also discuss how they are building a GraphQL as a service platform. Before we get to that episode, a few quick announcements. The Software Engineering Daily community has been working on a project called Software Daily. Check out softwaredaily.com to find the repository for a project that is an open source news and information site about software. I think this can be a really powerful project, and we really want to see it come to fruition. So if you're a developer, please check it out. You can also go to softwareengineeringdaily.com, where you can find links to this show's Slack channel, my Twitter account, my email. You can sign up for our newsletter, Software Weekly, which features curated content that the Software Engineering Daily team is checking out on a daily basis. And with that, let's get to today's episode about Scaffold.io and GraphQL as a service. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Vince Ning and Michael Paris are the creators of Scaffold.io, a provider of GraphQL as a service. And today we're going to be talking about GraphQL and GraphQL as a service. Vince and Michael, welcome to Software Engineering Daily.
Hey, thanks for having us, Jeff.
Yeah, we're excited to be here.
Okay, great to have you. So let's start by talking some about GraphQL. I think a lot of listeners are not super familiar with it. What is GraphQL?
Yeah, so GraphQL, it's an applications layer query language that was created at Facebook that basically serves as a replacement for REST. So it provides a new way of interacting with that client-server interaction that Facebook built kind of because I think they ran into scaling problems where they had so many different data sources and so many different applications that needed to pull from it that they kind of created this GraphQL thing to conglomerate them, to consolidate all of those different sources into a single API.
What are the problems with REST?
Sure. So REST, in our eyes, a lot of the problems fall into inconsistency. So there's no de facto way of building a REST API, so everyone ends up rolling it themselves and doing it their own way. Another big problem is there are just too many endpoints. So every resource is designated by a different endpoint, by a different URL. That can get really hard to manage at scale. Another issue is there's no cooked-in data validation, so every REST API ends up having to do its own custom, its own custom way of validating and cleaning data, whereas GraphQL it's kind of cooked into the library. And the other problem is that it's opaque. So from a client perspective, a REST API is kind of a black box, and if you have to have outside documentation to really understand what's going on in there, and without it, you're kind of stuck. Which is why a lot of providers of REST APIs end up distributing their own SDKs to kind of I guess, block the user from that headache. But it's definitely a problem that people are dealing with.
True. I guess that's a sign that there is something wrong with the underlying technology when everybody essentially builds an SDK on top of it.
Right.
Yeah.
So Netflix and Facebook both had similar projects at the same time where Facebook built GraphQL. Netflix also built a project called Falcor that was similar to GraphQL. And these things came up totally disconnected with one another, but they kind of do the same thing. Explain why both Facebook and Netflix were facing the same problem.
Yeah, so I think I kind of touched on it earlier. I think a lot of it was driven by these growing pains. So they, as these companies were expanding, their services were expanding. They had so many different microservices oriented for different things that were all, they could have different data stores and different APIs, different structures of different APIs. That their client apps were just experiencing a lot of pain trying to figure out how to pull data from these things. So Netflix coming out with Falcor, the distinction in my eyes is kind of that Falcor is more of an implementation, whereas GraphQL is a language spec. That's actually why we think GraphQL is going to become much way more important in the industry than Falcor ever was. But yeah, so essentially all of these different apps needed a way to pull all of these different data sources consistently. And Falcor kind of uses this idea of the virtual JSON structure, virtual JSON document, whereas GraphQL uses this hierarchical language to do the same thing.
Right. So getting a better idea of what GraphQL does, there's a GraphQL server is the notion of this single endpoint. And so whether I have all the data about my advertisements and they're all in Cassandra, or I've got a bunch of data about users and it's on Amazon S3, the GraphQL language will unify these into a single endpoint, and that endpoint is the GraphQL server. Explain how GraphQL unifies these different data source endpoints.
Sure. So GraphQL kind of in REST is also hierarchical and is able to do the same thing in a way, but GraphQL does it by the combination of its hierarchical type system in addition to its mechanism for how it resolves data. So if you build a GraphQL server, something you'll quickly notice is that implementations of GraphQL of the library are essentially just a parser combined with an event router. So essentially, when a request comes in, it'll parse it, it'll decide which, what types of data is the client asking for, and then it'll route events to different, functions that know how to get that data. So that's really the power, is that it's totally data source agnostic. So when in a GraphQL query, you can ask for something that can pull from 5 different places, and it's just sorted out for you by this resolution mechanism, this system of resolvers, is what they call it in GraphQL.
Okay, and GraphQL provides a declarative type system. Can you explain what that means?
Sure. So declarative is what, not how. So if you think of like declarative languages, SQL comes to mind. So in SQL, you say what data you want, and you leave it up to the compiler and the query engine to figure out how to get it. On the flip side is something like Java, where every step you're saying step 1 is this, step 2 is this. That would be imperative. So the declarative part of GraphQL is that you say what you want your data to look like, and you define this hierarchical data model of what you want it to look like without ever having to really worry about how that structure happens or like the step-by-step process to getting it there.
So you rely on the server to interpret the what and implement the how.
Exactly.
Yeah,
exactly.
And I think that also speaks to the power of GraphQL because of the fact that it's its own language. So it's kind of heavier weight than Falcor because you have to build your own GraphQL server to interpret that language. But it does allow you to do more like this declarative type system, for instance.
So if I make a request to my GraphQL server for a bunch of different data types in a single query, and the request has to go from the GraphQL server and fetch it from 5 or 6 different data sources, am I suffering from the latency of the slowest member of that request?
So that's a problem that GraphQL is definitely trying to address, because there is the concern that if you have a bunch of different data sources, are you succumbing to the least available of them? There's some cool projects coming out, or some work going into kind of making it more of a, if one of five fails or is slow, then the other four will still succeed. So we're seeing that come out. But it does depend, and there are ways that in your own implementations of these systems you can prevent that from happening.
So, does GraphQL have some caching built in? Does the server cache anything, or does every request get a fresh mound of data?
So the GraphQL implementations themselves do not have a caching layer built in, but there are a lot of really cool tools that you can use to build it into your GraphQL server. One of our favorites is a data loader project, which is also built by Lee Byron at Facebook. And they built that project, and it was inspired by a lot of the work that Facebook did in making basically a per request cache. So in any given request, you will never make two requests for the same piece of data on the server side. And then there's also a lot of cool work going into client-side caching. So the server-side caching is one problem. Client-side caching is another. And we're seeing a lot of cool work going into, for example, Relay or Apollo Client. They both, I believe, use Redux to basically maintain client-side state and to cache client-side data to basically cut down on the number of requests needed in general.
Okay, so how does a user specify the schema of different things that the user is going to be requesting? Like, what is required in setting up? Like, this is the thing I always hear about GraphQL, is that setting up the GraphQL server is difficult. Setting up the way that GraphQL intertwines with all of my different data sources. How does that process work?
Sure. So in its base, you basically have to define a type for everything in your data. This is why it can be kind of confusing, especially if you're coming from a REST background, because everything is typed. So even in essence, even like your functions to get the data adhere to types. So you begin by defining your data types. You also have to define these things called input types for any parameters to be passed into your GraphQL queries, and then you're writing resolvers. And that's kind of the problem that we ran into, which is something that inspired us to start working on Scaffold, is that we saw that GraphQL was really powerful and we wanted to be able to use it. And we had both worked on, different REST APIs in the past, and we're like, this is just so much better. Like, I'm never going to write a REST API again. But then as soon as we started to build the thing, we were like, wow, this is non-trivial. This is hard. This is a totally different way of thinking about things than we had been thinking about things before. So that's kind of part of what Scaffold does is we actually just we just store metadata about what you want your structure to look like, and then we basically do a giant tree walk that is attaching resolve functions to your type system, which is kind of how your entire your GraphQL schema gets generated and is totally custom to what you define. So it's something that we're foreseeing a lot of automation coming into. Apollo Server, another kind of open source project for building GraphQL APIs, has a similar functionality to what we use on our backend. So we're going to see that more and more, we think.
Okay, so I want to get more into Scaffold eventually, but let's just talk a little bit more about the world agnostic of Scaffold, just setting up GraphQL.
Sure.
What are the hurdles that I have to go through to set it up? What are the challenges of maintaining the schema, the challenges of maintaining the consistency between how the GraphQL server works and my different databases that are changing schemas all the time? Why haven't we seen more people using GraphQL?
Yeah, so I guess another thing is there's definitely an overhead to maintaining. You're essentially having to maintain two type systems, because if you're running SQL, you've got a schema in your SQL that adheres to its own type system, and then now we're saying, okay, you've got to go build that type system again, and you've got to expose it at the server. So that's definitely one. Is there's a lot of overhead to structuring the server up front. That especially, if you have a changing schema in SQL, then you're going to have to change your schema in GraphQL. There are ways to get around it, though. Like one of the nice things is, for example, say you've got a bunch of client apps that are hitting a GraphQL server and your SQL has to change. Before, it would probably just break because I'd assume it's some sort of pass-through. You're doing a SQL query and then you're passing the data out. A cool thing you could do with GraphQL, though, is if your schema in your server or in your SQL changes, you can actually just map the new data, the new schema, to your old schema, and you never have to break anything on the client side, which is a really nice thing. Another good part of GraphQL is it solves a lot of versioning issues like that. And then another kind of side effect of GraphQL that is nice is when these schemas are changing, you can basically just mask data. So if you don't want some data to be readable, if you leave it out of your GraphQL server implementation, out of the type system in your server, then you will not get that data passed through from SQL, which is a nice way to just hide data.
Okay, that's cool. So if you want to expose a limited amount of data that from an API that has a giant surface area, then you can just only implement a partial schema.
Right.
So did either of you have personal experience building apps with GraphQL before you started Scaffold, the GraphQL as a service platform that you're building?
Actually, no. Yeah, we did not. We kind of just like earlier this year, beginning of this year, we follow Hacker News a lot, which is Y Combinator's news source. And so like we just kept seeing like at least like a couple times a week, GraphQL would pop up as like a pretty hot topic. And so we took the library and started playing around with it to see what we can build. And we thought that the overhead was pretty high, and so like we thought that this is such a cool technology with a lot of great benefits. So why is it so hard to implement before you start seeing the magic? And so what we kind of set out to do is like, let's just make it easier for everyone to set up and build and deploy GraphQL servers, and be able to like feel the magic before having to actually worry about or like trudging through the plumbing.
Are there people out there that are using GraphQL in production, or is this mostly something that Facebook open sourced, but only Facebook is working on? Like, what kinds of companies are actually using GraphQL?
Yeah, so I think like Facebook's definitely the biggest one. They released it, they made it, but then like there are definitely a lot more startups nowadays using GraphQL, at least in part, in some fashion in their system. So for instance, like we're in this Y Combinator batch, and there's like another company called Beak that uses GraphQL. I think Intuit also uses it, and New York Times is also using GraphQL. So a lot of like large production sites are using GraphQL to power their apps.
Yeah, I've read that Twitter is using it. Also, Meteor.js is doing a lot of really cool GraphQL work. Kadira is another one. There's a lot of it is just building out a lot of tooling, which is really cool. The community is rapidly growing in that aspect.
How do these companies onboard with GraphQL? Because this process of setting up the schema sounds pretty onerous. It sounds like every team that has some sort of data source would need to spin up their own or define their own compatibility with the central GraphQL server. So a reminder, just for people who are still not very familiar with GraphQL, what happens is I make a request to GraphQL, and the GraphQL server federates that request. It sends out sub-requests to all the different data sources that need to be that need to service that overall data request. Like if I'm requesting data from users and ads and movies, then that is a single GraphQL request. All of those requests might get that might get federated into 3 different requests to 3 different data sources. And so the owners of the services that are those data sources, like if I'm a person that owns the user data source and I'm a person that, or a different person owns the movie data source, those different people have to implement ways to comply with the GraphQL request. So it makes me wonder about what the implementation process is for deploying it at a large company where there's a variety of service owners.
Yeah, so I think one answer to that is that you can do it iteratively. So there's nothing that says you have to replace everything in your system with GraphQL, and you can kind of slowly onboard. And with that, you can figure out your own process. So, most of these services, most of these companies, I assume, have some sort of REST API or something exposed that already has its own type system cooked in, even though it's not explicit, but in some way there's a structure to the data. So what you can do is just slowly but surely implement smaller and larger parts of the GraphQL server to talk to different parts of the system. So you could start with just users, for example, and then move on to movies, and then move on to everything else, and then slowly translate from your client app from REST or however you're doing it to a GraphQL interface.
I want to go through a few more definitions and basic explanations for how GraphQL works before we get into Scaffold. Could you explain what a connection is in GraphQL?
Sure. So connection is a standardized way of paginating through large sets of data. So if you think of, let's just take like a blog, for example. A post in a blog might have 1,000 comments, or a post on Facebook might have 1,000 comments. You have to figure out a way to slowly pull chunks of that related field. In GraphQL, they standardize that idea into something called a connection, and a connection is essentially a set of edges. Each edge in a connection is associated with some opaque identifier that they call a cursor, and that's basically how you handle the pagination. Is you can say things like, I want the first 10 comments after cursor X, and then that'll return the 10 comments that fall after that cursor in some series. Then you can say, after you get that chunk, you can say, I want the first 10 after cursor Y, and then that takes the next chunk. And it's essentially just a standardized way of doing pagination, and it does pagination well in that it uses the concept of this cursor, to make sure that you're not returning duplicate data. So like another example, if you're writing some sort of SQL schema and you want to be able to do pagination, the ultimate no-no is to use basically like a select where and then use an offset. So a lot of like naive pagination implementations will just say, I want the first 10 things, and then I want elements 11 through 20, and then I want elements 21 through 30. But that actually ends up causing a lot of headaches and problems, because if some new piece of data is inserted in between those two calls, you're going to get that same piece of data back twice. So connections are a way to standardize that idea using cursors, so that never happens, and then allows you to do kind of nice complex pagination on any type of related data.
Okay, so actually, let's go ahead and get into Scaffold. So what is Scaffold.io?
Sure, yeah. So Scaffold.io is a GraphQL as a service platform. So we kind of present ourselves as one API to access all of your services. And so what that kind of carries over to is the power of GraphQL and its ability to consolidate multiple data sources, existing data sources, hosted anywhere and however you're implementing it. And so what we do is, as soon as you go on our site, you can create an app, and as soon as you do that, we generate a GraphQL server and give you a GraphQL API back. And in that process, you can define your data models, how you want your data to be related to each other, the types, and without having to write any code, you have an entire GraphQL server with the schema generated for you already. So that's pretty powerful already. And then what we're really focusing on nowadays is the integrations. So, this kind of plays into the whole data consolidation aspect of it. The idea is not only can you build your core data platform and store the data on Scaffold, but you can also integrate with existing data sources or services that you have already. For instance, like if you're building like a charity platform, you'd have to have some way of like accepting payments. So, we have like a Stripe integration where you just give us your API keys, and immediately as soon as you turn the integration on, your singular one endpoint API will expand to include the queries and mutations that are allowed for interacting with Stripe. And it all passes through, one single API. So from a front end perspective, that makes development way cleaner and code design way cleaner as well. So, not only can you do services, but we have, we're drawing up plans to basically be able to integrate hosted data sources as well. So, for instance, if you had some sort of like SQL database on Amazon RDS, you could give us credentials for that, and we'd be able to like access the data on your existing data store without having to migrate that directly over to Scaffold. So that makes development way easier. And the idea of unifying all these data sources is kind of what we are intending to go after.
Okay, that's a lot of useful functionality, but let's step back and talk about just the GraphQL component of Scaffold. So how does the experience of using a Scaffold compare to the experience of just rolling my own GraphQL server and schema and everything?
Yeah, so I think Michael spoke about that a little earlier, and the idea is like rolling your own GraphQL server and schema is definitely a way to do it, and I think a lot of people are doing it that way. However, the overhead of doing so, maintaining all your types, that's kind of that'll probably eat up a lot of your time as a developer. And so, what we serve to do is help you build that server and schema and generate these types really quickly and easily in an automated way so that you don't have to worry about that. And you can kind of just like, you can utilize the benefits of GraphQL without having to like manage it.
Right. So one of like the best, our customers, one of the things that they praise us the most for is we have this portal, this panel called the Schema Designer. And it kind of it hides all of the complexity of figuring out the type system, of building the type system into you see your data model as types, and you say I want a blog, and a blog's going to have a title and a bunch of posts, and a post is going to have a title and some content and a bunch of comments, and you can basically just by clicking buttons, you're just choosing defining types, choosing their type, adding fields. And in the background, we're handling all the hard part of, spinning up these types, making sure that your schema is consistent. As your schema changes, we're doing things to migrate the data in your schema. So, there are these concepts of non-null. So if you're adding a new non-null field and you don't have data for that field in your existing data set, then that would break your GraphQL type system. So we're doing things like, automatic migration and having default values and rolling things back so that you can, as your type system evolves, as your schema evolves, your data sets will always adhere to it. And there's actually a fair amount of logic that goes into that migration step that you're going to have to implement yourself or manage yourself if you roll it your own. That's kind of transparent and you don't even know that it's happening in Scaffold.
Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SEDaily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SEDaily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SEDaily. Thanks to Wealthfront for being a continued sponsor of the show. Now, let's get on with the show. Are you storing the data for Scaffold users?
Yeah, currently we do. We're like a persistent data platform. So basically we handle everything from the API back to your data store and scaling and everything else as well. So currently, if you wanted to start a new app, you could do so on Scaffold. And, we have plans to be able to integrate existing data sources as well.
So what is the underlying data store of Scaffold?
Yeah, so we use RethinkDB. And it was a choice early on that we made for a couple different reasons. One, it fits in this really nice middle ground between like SQL and NoSQL. It has a lot of the things that you want to be able to do in a GraphQL type environment, like joins and things like that. The other thing that it provides is it gives us real-time functionality. And we have a lot of plans for providing real-time behind GraphQL. So like a real-time messaging system behind GraphQL. And in GraphQL, that's kind of it's part of the implementation. It's yet to be part of the spec, but it's this concept called subscriptions. So subscriptions are GraphQL's way of implementing this real-time functionality such that it's almost like a pub subsystem. You say, I want to subscribe to my user table. And then every time that a new user gets created, I would get pushed an update instead of having to poll for an update. So that really allows us to do things like messaging clients. And it's something that we're thinking about a lot now is how can we provide this this functionality, the subscription functionality that will work with the client libraries out there, things like that. And our choice of Rethink was kind of directly towards that goal.
Yeah, we did a show on Rethink last year, and if I remember correctly, Rethink is somewhat unique in that it has push-based functionality. So the database will push data to you. It's not just, hey, select star where user is whatever. It's the user table gets updated, like you said, and RethinkDB pushes you the updates, and you're just, rather than constantly having to pull the database, POLL, pull for changes, or you could say PULL, I guess. Interesting. So what other, talk a little bit more about RethinkDB, because I think that's a really interesting choice. It's a unique choice. How did you settle on using RethinkDB? Did you look at other options? Were there some trade-offs or compromises that you're making by selecting RethinkDB as the underlying data source?
Sure. Yeah. I mean, like the other obvious choice was probably Mongo. We chose Rethink a lot because of that subscription thing I was talking about earlier. But there's also it's one of the easiest databases I've ever used, and its ability to manage clustering with a small team is amazing. So we're a 2-person team. We run a distributed database service, and Rethink handles it uses Raft to do leader election, master election, things like that behind the scenes that just totally take a lot of the burden off of us, which is really, really nice. The other thing that it has is it has a lot of just awesome built-in functionality for things like location services. So the other day, we rolled out location services on Scaffold to basically allow you to do, you can add a location field, and then we'll automatically create a geo index on that field and allow you to do things like get nearest X or get all X within some arbitrary geographic location. Things like that are really nice. And then but there is, we've yet to see, no one has come nearly close to our capability to handle queries yet. So we're interested to see, if there are any scaling problems. We don't foresee there to be too many, but that's an interesting problem. The real-time aspect is really cool. So we're excited to see where that goes too.
Okay, scaling. So what are the typical, that unlocks a lot of discussions. We could talk about scaling RethinkDB or scaling. So for those who are unfamiliar, I think RethinkDB is open source. So I imagine you're hosting your own version of it or your own deployment. You're not using RethinkDB's hosted option. I think they have hosting. So you could talk about the challenges of scaling GraphQL in general, or the challenges of scaling RethinkDB. And it sounds like you've already thought about that because you're saying that you don't have scaling, or you don't think you're going to run into scaling limitations. What are the interesting scalability conversations to have here?
Sure. So, this kind of goes back to the ease of Rethink scalability. So we run essentially all of our services via Docker containers, which is a really great place to find yourself in if you're building a new service, because scaling is much easier than it would be otherwise. So we're interested to see Rethink claims that it's basically a linear growth in scalability. So the more servers you add, the more write throughput you're going to get, the more read throughput you're going to get, things like that. So that's really nice. We can kind of just throw hardware at a problem for now. In terms of the GraphQL scalability, it's kind of the same thing. We run all of these things on Docker. So it's something that we've got everything is load balanced, things like that. So we can basically throw more instances at the problem for now. And it's really worked out nicely that it will scale as we do that.
Okay, well, that's a pretty simple scalability story. That sounds convincing. So if I'm a CTO and I want to have my company start using Scaffold, I want to start using GraphQL, so I'm going to use Scaffold's GraphQL as a service. How do I onboard?
Yeah, so the idea is like you'll basically want to define a schema that's kind of like the keys to the kingdom right now, where basically you define your types and your data model, and then if you wanted to use your existing data source, that'll be coming soon. That's a feature that's coming soon. But right now you'll have to come talk to us about how to import your data into our databases so that we can grab it for you and basically spin up your entire GraphQL server for you. Also, like if if you have any like other existing data sources hosted in any location, the capability that will have soon is to be able to tie those into your existing GraphQL server. So you'd be able to like build a schema and use our persistent data store in combination with your existing data stores as well.
Okay, so let's first talk about the current use case, which is you pull in people's existing data stores. You have to migrate them to Rethink. Is there a standardized way? So if you're talking to some company that has some MySQL servers and some Cassandra servers and some, maybe Mongo, do you just migrate each of these on an ad hoc basis and figure out how to do it, or is there a standardized way for each of them?
Well, Rethink has a standardized way of basically exporting and importing its own data. But yeah, for now, we'd probably ask for it in some sort of JSON format or CSV format, and then we could just be able to map it from that format to your schema, and then kind of seamlessly update like that.
Okay, that makes sense. Okay, so let's talk about the more interesting conversation, integrating with their pre-existing platform. So if you're talking to a company that it has, like I said, Cassandra and MySQL and Mongo or whatever else, how are you architecting that new feature where you can integrate with their pre-existing data platforms?
Yeah, so we part of our platform is this whole integrations system. So we've kind of built out this custom way of adding chunks to your GraphQL API, because the whole idea is your API is going to expand only when you need it. So as you add integrations, the functionality of your API expands. So it'll kind of fall into that same area as basically you'd be able to say, I want to link my API to some Postgres instance on RDS. For us, basically, that just means you can go on RDS, you create a user account that you give X permissions to. Say you only want us to be able to read, then you could do that. If you want to give us admin access, you can also do that. And then we would actually be able to go and, because SQL keeps type information on your schema, we would actually be able to automatically go read that type information, make a best guess as to the structure of your data, and then you could therefore, like after that, you could finally tweak it. You could fine tune it. So then the idea from our perspective is make it as simple as possible. You give us a URL and a user account. We'll go see what we can find out. You can fine tune it, and then automatically you've got these mutations and these queries that allow you to interact with it.
Okay. What are the other challenges that you're encountering as you try to implement this integration with anybody's pre-existing data?
Yeah, so another really hard part is that if you've got your own RDS instance, you're probably using things like stored procedures or things like that, custom logic, your own complex queries, your SQL queries that we necessarily won't be able to figure out. That's another problem. We're trying to think of a way to securely allow you to basically define your own mutations and define your own queries that you can write your own complex logic for. So for us, it might look like in our web portal, you'd have the ability to kind of insert in queries and mutations and then have a little text editor for SQL. And then it'd be something that we could, we're going to trust you. You gave us this user account. We're going to trust that you wrote this SQL that is valid. We're going to run it and then return the data that adheres to some type that you defined in Scaffold.
Okay, so talking some more about the basic functionality that you can get out of Scaffold, explain the permissions system and why this is useful.
Sure. So we actually have huge plans for this. The permission system is basically a way to implement complex access rules without having to write any code yourself. So this is something that we often get asked about is how do you handle access control in GraphQL? And essentially the way that we've done it is we let a couple different types of permissions. The highest level is probably role-based. So every time Scaffold as of now manages your user model. So you can assign, you can enroll users into different roles. You can then put role-based permissions on every one of your types. So you can say, I want only my admin role to be able to create type X. We basically then cascade that type and that role information through your schema as it's executing. And then in every mutation and every query, every operation type, so for example, create or read or update or delete, we check that role information. So that's one option. The other options are what we call related permissions. So a related permission would be something like, say I'm a user and I have a bunch of posts and I am the author of those posts. We ideally would be able to say, you can only update a post if you're the author. So that's kind of the related type permission, and we have systems that allow you to do that. There's also authenticated permission, which is if you're not logged in, then you don't have permission, and then there's everyone, which leads to everyone can be able to do something. So right now that works really well with the data that you store on Scaffold, but we've got big plans to move it to everything. So all of your integrations, we want you to be able to permit different access rules to. And that almost adds another level of service on top of everything else, is that now Scaffold is this ability to delegate, permissions. It's like IAM, it's like Amazon, the identity access management, but for the entire internet.
Mm-hmm. Okay, interesting. So let's kind of go through an example. Walk me through the end-to-end request response pattern of a read using Scaffold.
Yeah, sure. So basically the idea is you make a post request to the GraphQL API that we offer you or that we give to you for every app that you make. And as soon as you make the post request, you're passing in a payload with the format of a query string, which is your GraphQL query string, and the variables that, the optional variables that are passed into the query string if you need them. And that's encoded in JSON format. And so as soon as you make a post request with that payload, what we do is, Michael's talking about the permission system. It first checks the authentication token and makes sure you're a valid user for this schema to execute queries upon, and also verifies that your permissioning validates as well. And then after that, what ends up happening is the GraphQL picks up the query, routes it to the specific event handler, for instance, get user by ID. And basically you're passing the ID. In that resolve function, we'll take that ID, and we've implemented a way to connect to our Rethink database to your schema specifically, and grab the user that belongs to that ID. And then we route that and we pass that back to you. So that's kind of like the end-to-end response pattern of a read in GraphQL on Scaffold.
What about with a mutation?
It's basically the same type of deal. Instead of passing in a query, you're passing in a mutation, and a mutation has an input type. So we generate all those for you. So that's another benefit. You don't have to code that up yourself on the server. And input type basically requires a payload, a JSON variable payload. And it's the same sort of deal. You make one request, passes through our authentication and authorization permission system, and then we route the request through GraphQL to grab you the data that you need and execute it on your database.
Yeah, and another interesting distinction about mutations is that they're officially it's an operation, a changing operation, something that'll change something followed by a get. So you're always going to get back the most updated version of whatever data you're changing.
Mm-hmm. Okay, so now that we've gotten through the components of the kind of the basic GraphQL aspects, I want to get back to these integrations because, as you said, Scaffold integrates with these services like Facebook authentication and Slack and Stripe. And, when Vince initially told me about this, I was like, okay, cool, GraphQL is a service. It makes a lot of sense. But then I started to read about the other things. You have these integrations. Why would I want GraphQL to integrate with these things like Facebook authentication and Slack and Stripe?
Sure. So, we mentioned a little bit on it, but due to the fact that all of these different services are normally exposed via a REST API that is inconsistent and really hard to work with unless you're using an SDK. So one of the great benefits of GraphQL is A, its type system, and B, its ability to introspect itself. So that opaqueness problem with REST I was talking about earlier, GraphQL kind of solves it with the ability to query its own structure. And in that way, it basically cooks documentation into the API itself. So it's nice from our perspective because we're able to create these integrations that pull in data from all these awesome services, for example, Stripe. And then we're able to expose that and cook their documentation into our Stripe integration so that when you're using it through our portal, you don't have to go hit Stripe's docs page because it's built right into your API and you're seeing it from our portal as well. The other part is the type system. So you get data validation and helpful error messages just out of the box because GraphQL is sitting in front of it. The other side is you can, it's the whole single API. If I'm writing a mobile app and I need Stripe payments and I need email and I need data, otherwise, if you're doing it without us, you're going to have to download 3 different SDKs. You're going to be hitting 3 different APIs. You're going to be hitting, you don't even know, they might operate differently. There's no ability to really relate them or have some system of relation between those data types. With our integrations, it really just seamlessly follows the GraphQL model, the hierarchical model, and can join all of those sources together.
Yeah. And you don't have to use any SDKs either.
Yeah.
So there are these services that are like integration platforms, and some of them are Y Combinator companies. I'm thinking of something that starts with a Z, like
Zapier.
Zapier, that's right.
Yeah.
So is that similar to what you're building, like Zapier, but instead of RESTful, it's GraphQL-y?
In a way, we kind of see it as a more programmable Zapier. Because you're actually programming against it. Zapier is awesome and has a lot of really cool ways of linking different events, and they have their trigger system and actions, and you can pull together all of these different services to do kind of simple directional flow here. Whenever an email is created in Gmail, I want a Trello item to be created, things like that. We're kind of seeing it more as like we want to be more of an API, this is something that you can program and write code against to really implement anything, to totally customize your workflow. But there is a distinction there that the GraphQL services part of it we think makes a lot of sense just because that's what this technology was built to do, is to pull together these disparate data sources. And it really is a natural evolution for this integrations type service. Mm.
Another worthwhile comparison between Scaffold and something else is Firebase. So Firebase is a back-end as a service product. How does Scaffold compare to Firebase?
So Firebase, I guess, specializes in real-time functionality. So in that vein, we're not quite there yet in the real time, but it's coming. So a lot of it, other than that, is very similar. Though they have a data store. They allow you to define input data. They don't have a type system though, so it's a little different.
So you need an SDK.
Yeah, and the other thing is you have to use an SDK. So Firebase they expose some sort of, I'd imagine it's not RESTful because of the real time aspect of it, but they're doing some magic with WebSockets that are going on in the background, and if you don't use their client libraries, you're not going to be able to use Firebase, which is kind of a problem because they're distributing those SDKs, and if you want to build for a platform that doesn't have one of those SDKs, good luck. Mm. Another thing about our service is that because it's GraphQL and everything is essentially just strings being sent over the wire, you can really write it from anywhere. You write your query one time, you then literally copy and paste that query to all of your different client frameworks, and it works the same exact way. You're not writing it once in Swift and once in JavaScript and once in Android to do the same functionality. It's that kind of dry. It's a very dry approach.
Mm-hmm. And GraphQL is one of these tools that came out of Facebook in the last couple of years as Facebook has really ramped up its open source efforts, and this also includes React and Relay. What is your higher level view of this set of tools, and how do you think about that from a product perspective?
I think it's great just overall. Google has like Angular, Facebook has like React and Relay and stuff. And what's really cool about React is that it's kind of this more functional approach to front end development. And with that comes like all these tooling like Relay come out of Facebook, Apollo Client, which is, Meteor's, front end caching framework to interact with GraphQL. And all these tools around such a unique front end framework really bolsters kind of the popularity of it. And a lot of people are, developing on React nowadays using GraphQL. So they play very well, like nicely together. And it makes the development experience much more enjoyable as opposed to trying to like hack together different technologies built by different companies that weren't necessarily designed to play well with each other.
Mm. How does GraphQL fit into the conversation around serverless architecture?
Yeah, so GraphQL in general can definitely work. Our service, we really are trying to approach that because we have basically a way of doing webhooks that you can use your GraphQL API to issue webhooks that then call something like an AWS Lambda account, so that your infrastructure is managed totally by something like Amazon and follows that serverless kind of microservice architecture. It is also totally possible to, if you wanted to host your own GraphQL server in a serverless fashion, you could 100% upload a Lambda function that implements your own GraphQL server, and then that just scales so easily. You're still going to be doing a lot of the hard part that we've been talking about, the type system and everything like that, but it is definitely something that is possible in a serverless architecture.
So what would the scalability story look like there to drive it home further? Because obviously you can scale up the GraphQL servers in a serverless fashion as needed, but would you also need to, I guess you would also need to be scaling up the services that stand in front of the databases that the GraphQL queries are being federated to?
Definitely. It still depends. It's still going to depend on the backend data store.
Okay. Interesting. So what's your business model?
So we currently bill on basically like two metrics, which are, we try to keep it simple, just request logs and, number of requests and the amount of data we store for you. So the idea is like, we have a free tier, we have a startup tier, and an enterprise tier. Currently for the free tier, you get up to 2 gigabytes of storage and 500,000 free requests. And after that, you bump up to the startup tier, which is only $9 a month. So, basically for all your development costs, you really won't have to spend any money. And we just want you to be able to like use our service without having to worry about cost, at least up front. And that's kind of our business model so far.
So to close off, what are the aspects of GraphQL and, well, I guess I should say Scaffold. What are the aspects of Scaffold that you're focused on most right now? What are you building?
I would say like more integrations. So, our core data platform is kind of, it's pretty stable, and we're obviously still making iterations on it as well to make it more complex. So it allows you to do more complex things. But integrations I think are the key here because it allows you to add large pieces to your GraphQL API without doing much work. Like with a few clicks of a button, you're able to like append all this extra functionality into your existing API, so that it also doesn't like affect the way your API worked before either. It's just kind of like an independent addition to your GraphQL API. So I think that definitely cuts down development time tremendously and costs as well.
Cool. Well, Vince and Michael, thanks for coming on the show. This has been a great conversation. I enjoy talking about GraphQL with you guys.
Yeah, thanks for having us, Jeff.
Yeah, thank you.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.